Alright, this section right here is Chapter 2, Section 5, Modeling Real-World Data Using Scatter Plots. Alright, this first example, we're given our table with our points. First step is plot the points. So we plot 1, 1, 3, 5, 4, 7, 6, 11, 7, 12, 8, 15. So our goal is to find out what y is when x is 10. So, next step, we draw a line through our points. Okay? You want to get the line as close to all the points as possible, which is why it is called a line of best fit. Okay? Line of best fit, because you want to try and make it best fit the points you've plotted. The next step is you want to choose 2 points from your graph to find a slope of that line of best fit. Okay? The reason why you want to find a slope for that line of best fit is it helps you predict what y would be when x is 10. So, when choosing points, you don't want to pick 2 points that are close together. Like, I wouldn't want to choose 4, 7 and 6, 11. The reason is because when they're right next to each other, it's going to make a harsh slope that will fall off, won't fit the best line of best fit very well. Whereas I chose 3, 5 and 8, 15 because they're far enough apart that they'll give me a good slope, and it will help fall closer to the line of best fit. Alright, so I'm going to find my slope with those 2 points, 15 minus 5 over 8 minus 3. That gives me 10 over 5, and that gives me a slope of 2. That's really nice. It's nice, obviously, having an integer as a slope. Oftentimes the slope will be a fraction, and that's completely fine. So we've got a slope of 2. And just like we've been doing earlier, now that we've got a slope and our points, we can use our point slope formula. Alright, y minus y1 equals 2, or equals m, x minus x1. And we can use either one of our points, 3, 5 or 8, 15, and our slope to get point slope form, which then I can make slope intercept form. So from here, I chose the point 3, 5. You could have chose 8, 15 if you wanted to. That doesn't matter. But I plugged it into my point slope formula right here. Alright, and so from here I'm going to distribute the 2. Gives me y minus 5 equals 2 x minus 6. Alright, I will then add 5, and I have y equals 2x minus 1. Alright, well, that is perfect. That is in slope intercept form, but that's also called my prediction equation. Alright, with my prediction equation, whatever value I plug in for the x, it'll tell me what that y would probably be. So I was trying to find what y is when x is 10, so I'm going to take 10 and I'm going to plug it in for x. Alright, so that'll give me y equals 20 minus 1, which gives me y equals 19. So when x is 10, y is probably 19. If you had chosen two different points other than 3, 5, and 8, 15, it's going to be different than 19, but it will be probably somewhere close to that. Okay? Next example. Again, my first step is to plot my points. 5, 9, 10, 17, 20, 22, 25, 30, 35, 38, 40, 44, and then I'm going to do my line of best fit. Okay? Line of best fit. On this scatter plot, I chose the points 5, 9, and 40, 44. Okay, 5, 9, and 40, 44. Don't have to choose those two, but try not to choose 2 points that are right next to each other, especially on this one. It would be a really harsh slope that would be off of our line of best fit. So here, I'm going to find out what my slope is. 44 minus 9 over 40 minus 5. That gives me 35 over 35, which gives me a nice slope of 1. Alright, gives me a nice slope of 1. So from here, now I can choose either point to plug into my point slope form. Alright, well, I'm going to do y minus 9 equals 1, x minus 5. So I chose the point 5, 9. Could have done 40, 44. Does not matter. I distribute my 1. Y minus 9 equals x minus 5. Add 9. Y equals x plus 4. And that is my prediction equation. Alright, so now I can predict what y would be when x is 50. Plug in 50 for x, and that gives me y equals 5. Y equals 5. Alright, so if you'd use 2 different points again, or y equals 54, I'm sorry. So if you had you had used 2 different points, you wouldn't exactly get 54, but you would be close to that, somewhere close. It shouldn't be too far off. But again, if you chose 2 points that were close together, like if you had chosen 20, 22, and 25, 30, you would not even be close to 54. Because if you look at that angle of those 2 points, that is way different. Okay? That is way off. So that's a good example of why we want to pick 2 points that are farther apart for our best fit line. Alright, next example. Alright, same first step, plot our points. We've got 116, 216, 422, 530, 734, and 836. Okay. Drew my best fit line. This one's different because we're not trying to find the next point. We're trying to find the value of y when x is 3, which falls in the middle of our points that are already plotted. So here, you want to choose a point that falls on either side of the y value we're looking for. That first point right there, 116, that's called an outlier. An outlier is just a random point that falls way off our best fit line. We don't ever want to use an outlier to find our slope. because obviously that won't be very accurate for our best fit line. Doesn't fall close, so make our slope not accurate at all. I chose the points 216 again because I want to choose a point that's on the other side of what we're trying to find. And then I chose 422. Alright, and I know it seems those 2 points are side by side, but because of the X in between them, it'll work out fine, and it will put that point close to our best fit line. So for the slope, I'll do 22 minus 16 over 4 minus 2, which gives me a slope of 6 over 2, which gives me a slope of 3. Again, on all three of these examples, my slope has been an integer, right? And that makes it cleaner, but a lot of times you will get fractions, and that's okay. That's not a big deal. We do fractions all the time. So from here, I'm going to use my slope in either one of my points in point slope form. I chose the point 216, so I have y minus 16 equals 3, x minus 2. I'll distribute the 3, and I have y minus 16 equals 3x minus 6. And from there, we'll add 16. I have y equals 3x plus 10. Alright, this is my prediction equation. Now I can predict what y would be when x is 3. So I'll take 3 and I'll plug it in for x. Give me y equals 9 plus 10, which gives me y equals 19. Alright, so as you can see, that green dot on the graph, it falls close to my line of best fit. Though this is different, it's very similar to what we've been doing. Not very hard. Remember, the keys are to choose 2 points that fall close to our best fit line, okay? Preferably not side by side. Alright, and then from there, find our slope. After we find our slope, we use either one of the 2 points we chose to find our slope in our point slope form. Y minus y1 equals mx minus x1. Okay. From there, we distribute, put it in slope intercept form, which is our prediction equation, and plug in the x, and we're good to go. Alright, so you'll have another sheet for homework, and on that sheet, this is just for B2 and B3. My other classes, this is your homework. But you'll have a sheet. Just follow these steps. You can always rewatch this and get it down pat. Alright, have a good weekend.